Hello Chromian, and welcome to the FT4 Asset Management walkthrough. As usual, we're at learn.chromia.com, and I encourage you to navigate over, find the course, and follow along. Managing assets in Chromia is done using FT4, the flexible token library. But do go ahead and check out the links on this page. They contain very useful information on FT4. Here we'll take a practical hands-on approach, setting up a pool or a system account for the dApp, also some user accounts, and how to manage assets through minting, burning, transferring, locking, etc. We'll configure and set up the project, implement the underlying logic, and finally test the whole thing. The full implementation is available here in the repo that you can also use to verify your work. We'll start by setting up a dApp called Asset Management. Navigate to the project and open a dedicated editor. Okay, the default project comes with a hello world kind of file called main rel. But we want to make our project a bit more structured using multiple files. So let's delete the main rel file and its hello world tests. While we're at it, we can also create a directory called main that's going to hold our files. Now, you can choose to have more or less files, but we recommend dividing concerns into module, entities, functions, operations, and queries. So let's create those files in the main folder. Great! Now we have the file structure we prefer. We'll need to tell the compiler that this is a module. And we're going to generate a key pair for the token admin. If you need, the key pair is saved here in the file we specified. We specify dependencies in the Chromia YML and also the public key for the admin. Just go ahead and put it all in here, including of course the public key we just generated. And we should also install those dependencies we just declared. Perfect. Now we can continue with the basics of the actual implementation. Here's a quick overview of FT4, the flexible assets of Chromia's ecosystem. You can see the key components and features we'll be working with and the different account types we'll use. We also have our specific asset properties and registration, which we can go ahead and implement. Alright, that was the asset configuration. Let's continue to functions, operations, and queries. First, we'll define some helper functions, including things like retrieving accounts or getting the asset ID. We'll also extend the auth handler to require the transfer flag to ensure that users can actually transfer and thereby use the assets they receive. Let's put that in the functions rel file. Next we'll look at operations, starting with initializing the dApp, which can only be done by the admin. For minting and burning, we'll need an additional import. And the minting implementation, which of course also requires the admin. For burning, we retrieve the asset by its ID, so we also import the asset structure to hold that. And of course the burn implementation itself, including the admin requirement. There's also a faucet you can call as a user if your account can transfer. And of course transfer itself, also requiring that you're allowed to do so. The admin can lock or unlock your assets. We just need to import locking. Add the implementations with the admin requirement. Alright, those were the state-changing operations. Let's do some queries to check balances. Then we can verify what's happening. Great! We've now implemented all the core functionality. In the next part, we'll move on to testing everything we've built and see it in action.